Hey folks, it's Chris Wahl. Today we step into a more complex Terraform deployment. We're going to use private modules, we're going to use continuous integration, and the point is that we're going to build out those foundational resources used in this case, an AWS region. Now this is a pretty popular workflow, right? You have to build out the networking and the security and all the foundational resources that are used in the future by your applications. Let's get coding! Now, if you watched my earlier video about continuous integration, this might look a little bit familiar, but hey, if you're new, no problem. What this is GitLab. This is where I both host my code and I use the GitLab CI or continuous integration tool to actually push code into production. Now in the original video, we just built out that monthly budget you can see under AWS, and I've been kind of busy in the background building out everything else so that we can start building a more complex and robust infrastructure. You can see the utility group is where I contain the project manager used to manage all of these projects you see here, and my continuous integration templates that are used by the different projects. But more importantly, I built out a couple different AWS site deployments and a private modules group where I can stick modules that are used by other pieces of code. Now for this video, we're going to look at two things. The first, how is the private module put together and kind of what the code is and how we're describing the VPCs and transit gateways and all that jazz. Then we'll switch over to the actual project that controls the infrastructure deployed into US West 1 and see how it's calling that private module and what we're doing to make that as seamless and easy as possible for day-to-day operations. This is the project that contains the Terraform AWS site deployment module. I use it privately for most of my site deployments inside of AWS, obviously, and it's constructed out of different folders, and each folder is kind of its own module, if you will, to handle things like security groups, transit gateways, the VPCs, and VPN connectivity. And I have a little README in here just to make it easier for me, my team, whomever, to see what's going on, describing what all these different folders do, and kind of showing the topology of the architecture so that people know what they're building with this. It's also worth noting that I have a couple different branches. The main branch, which is the default protected branch for this project, and also this prod branch that's based off of the main branch. This will be important later, but I wanted to point it out now. I've switched over to Visual Studio Code so we can look at the content of this module a little deeper, and I've gone ahead and opened up the transit gateway folder and the different files you can see in there. And you might already notice there's a few differences here. Within the root folder of the module itself, there is no main TF or providers or anything like that. It's because this is reusable code that gets used elsewhere. So if we drill into this transit gateway folder itself, we can see a main.tf file, which looks normal. It's building things like a transit gateway, an external IP, things like that. Everything we need to build out the transit gateway. We also have outputs. The outputs contain values that are returned to a parent module when this is called elsewhere. And that's super important because we will be calling this elsewhere. This code doesn't run within this project. So whenever we work with variables and data and resources within Terraform, there are certain pieces of information and values that we need to return back to the parent. Don't worry if you're new to outputs within parent and child modules. I have a video that'll help you and I'll link to it right here. Additionally, we have variables defined for this folder so that we know what we're looking for and we're strongly typing those variables so that you can't input something like banana when you're expecting a number. Now, there's nothing special about private modules. In fact, there's a ton of public modules that you can use from AWS and Azure and everybody else. I just like building private ones because I'm opinionated on how I want to deploy my infrastructure. Public modules are great starting points, they're good scaffolding, but I always kind of want tweaks and things like that, so I usually end up building one myself. Now let's take a look and see how this private module is being consumed. And you can see here there's two AWS projects declared, one for US West 1 and the other one for US West 2. And that's in contrast to the private module that doesn't say anything about what site it's going to deploy. That's because it doesn't do any particular site, it's just code scaffolding that's used by these different projects. So if we go into US West 1, we can see kind of what's going on here. How is this being consumed? Well, there's no folders or anything here. That's because we're calling code remotely in that private module. And you can see here, there's some more information. We can see the region we're deploying to and what resources are going to get constructed. But I think it's best if we go to the code. Are you enjoying this video? Do you want some more? Click subscribe, click like. That's all it takes. It helps me out hugely. Thanks. Okay, this is where it's going to look really scary. Like there's a lot of stuff going on here, but a lot of what you're seeing in the code for the site deploy for US West 1 is variables and comments and things just to make it look pretty. Let's go through it kind of line by line and see what's going on here. Now in the first section, we have module transit gateway, and you can call a module any name you want. So I'm just calling it transit gateway. The first thing I'm telling Terraform is here's where you go get the private module. It's located at gitlab.com/Wahl network, modules, which is my group name where I store them. There's the git path, and I've got this / transit gateway with the ref equals prod. You can think of this kind of like an address where we want to go get some data from something, and so we have to pass this long URL structured a very specific way so that we grab that specific folder out of the Git repo, as well as a specific branch. That's why it says ref equals prod, because you'll remember I said we had the main branch and the prod branch. I only want to grab stuff from the prod branch. That way I have a little bit more control over what's being used by downstream projects that are consuming this module. Now that we know what the source input is doing for the module, it's just telling it, hey, here's where you go get the code, here's the folder, here's the branch. Let's look at what else is going on. It's really just input variables. So we need the tag name suffix and the tag environment, because tagging things is good, you should always tag things. And we're also getting information from other modules described in this very same main.tf file. So you see module.vpc-transit and then a VPC ID, subnet, all that kind of jazz. That's information being grabbed from other modules. And I like to just say the word parent in my input name so that it triggers in my brain like, oh, that's coming from somewhere else. It's being passed as an output from a child to the parent, and then we can give that back to the child module. I also want to point out a few places where I really try to keep this code as dry and stateless as possible, because these are the little tricks that make it so that your code is really, really reusable no matter what's calling it. So for example, under the module called VPC-transit, you'll see an input variable called AWS_subnets, and that's providing a list of private and public subnets to apply to different subnets that are being built out in the VPCs. Now, rather than describing the entire 4 sets of octets, like what specifically do I want for this /24, I'm actually grabbing the first 2 octets from a local variable. So rather than having that entirely written out every time and having to change that in the code over and over again, I'm using this variable so that I'm able to apply this kind of /16 supernet to encapsulate for all my different private and public subnets. It also means that if I don't want something to happen based on this kind of template, if you will, I can go down to, let's say, the VPN connection, and I can just comment that out, and the VPN will not be deployed into this particular site. So it gives me that granular control over everything I want within this particular site without having to take everything en masse or slice and dice things with hard coding. Because the main.tf file describes all the private modules to go check out and what inputs to provide them and how to pass information from child modules into the parent and even into other child modules, the only thing left is the locals file. Now, I will say that having a locals file to supply information into the project, it's kind of my own flavor. I don't see this done a whole lot. I like it because it makes it really easy for beginners and advanced personnel alike to just kind of see and say, oh, there's the locals file. It has, 8 or 9 variables in it, and that's what's supplying information to the project. It's written in Terraform, so if you know HCL, you're already there. And for me, simplicity is king. So that's why I do it, but just keep in mind that it may not be the way that you see it done in your environment. And here's the local.tf file. It contains a locals block, and I go ahead and put the Terraform block for backend remote state here. And this is kind of the personality of the project. Everything that's kind of stateful and hard-coded about the project is here. And that way I can clone this project as much as I want, and all I have to do is change the local file and the README to reflect, the name of the site that I want to deploy and things like that. But everything else, the CI file, the providers, versions, everything else is stateless. I could use it anywhere I want, and all I have to do is update these, 6 or 7 different values, and I'm off to the races. Another handy trick I wanted to show you is that you don't have to keep a fully hard-coded CI file inside of every project. It's totally fine to put a valid YAML CI file elsewhere. I use a project called GitLab CI templates in my utility group, and then just reference it. And in this case, I'm saying, for the GitLab-CI YAML file for this project, go to this other project called Wahl Network Utility GitLab CI Templates, go find the main branch, and then grab the file called tfprod YAML inside of the prod folder. Now let's see what happens when we take this project, we point it at a private module and say, go grab this stuff and deploy infrastructure into AWS. The first major thing that you'll notice that probably looks different than what you're normally used to seeing in Terraform is that when we do the Terraform init, we actually see all those different modules getting downloaded from those private paths. So we have the transit gateway, the different VPCs for services in transit and prod dev and things like that. Each module is being pulled from sometimes different branches, different paths to construct everything we need for this particular project. Once we have all the different modules and the providers and everything, then we're executing the plan. And you can see here, we've grabbed all that code, we've stitched it together using the project's main.tf file, and there's the module.transit gateway, module.services VPC, all of those things are actually described here. If we switch over to the apply job, I'm going to scroll down a little bit and you can see right there, we've gone ahead and grabbed the artifact from the plan job. So when we do the initialization this time, there's no need to re-download the modules and set up the backend. That's already done for us. Everything beyond this point is just about creating all these different resources, using Terraform to figure out the dependency mapping and graphing them to AWS resources. So there we have it, some pretty powerful stuff. We're just kind of describing reusable chunks of code that ourselves and our team will want to use to construct VPCs and VPNs and transit gateways and whatever it may be in your cloud environment. And then we're using unique projects and main.tf files and local information to say, go grab these different private modules, put them in this particular order, here's the values I want for them, and then deploy that using continuous integration and keep that maintained if there's drift or nightly changes or something like that to enforce the desired state. I hope you learned a lot and you had a good time, and if you could do me a favor, just click the like button and subscribe if you feel like it. That would be super awesome. It really helps this channel grow, and I appreciate your support. Until next time, happy terraforming.